right, today's lesson is for section 6.4 on rational exponents. We are going to learn how to go from radical form to exponent form using rational exponents. What I want you to remember is that when we were working in section 6.3, we could simplify a variable under the radical by putting the exponent over the index. Well, that's what we're going to do here too. We're going to put our variable down, and then we're going to put the exponent over the index. So that will give me x to the 2/3 power. That is the exponent equivalent to the cube root of x squared. Okay? We are going to use that in simplifying some of the radical expressions that we couldn't do before, but we will be able to once we change to exponent form. So for the first couple problems, we may go back to radical form for some of it. Some of it we may just leave in exponent form. We may do both for a couple of these problems. So when they ask me to simplify 216 to the 1/3 power, in my mind, I'm thinking, well, that means the cube root of 216 to the 1st power. So that's just the cube root of 216, which we know is 6. Okay, hopefully after you do several of these, you won't have to write this step down. You'll be able to see this step in your head. If not, write it down. There's no harm done. All right, for part B, if we stay in exponent form this time, we can follow the same rules of exponents that we did when our exponents were whole numbers. This is a multiplication problem. My bases are the same, so the rule says keep the base and add the exponents. So my base is 7, and then I'm going to do 1/2 plus 1/2 is going to give me 7 to the 1st, which is just 7. Now, let me show you how that is equivalent to what we've been doing in radical form. I know that 7 to the 1/2 is the same as the square root of 7. So when I multiply the square root of 7 times the square root of 7, I get the square root of 49, which is 7. Same answer, two different methods. For this problem, it does not matter which way you do it. Some problems will be easier done one way or the other. Okay? Almost all of them can be done both ways, but there may be a few exceptions to that rule. All right, for part C, this is also a multiplication problem, but the problem is my bases are not the same. So you've got two options. You can try to make your bases be the same, or you can work it in radical form. And I can do it in radical form because the denominators for both fractions are the same. So I know that both of these are 4th roots. So if we go to radical form, this is going to be the 4th root of 5 times the 4th root of 125. I can multiply those together, and I get the 4th root of 625, which is 5. That's my answer. It can be done pretty easily in radical form. But now I want to show you how to do it in exponent form, because not every problem will be able to be worked once you change it back to radical form, not without some extra effort. So what I want to do is I'm going to keep my 5 to the 1/4. But then I'm going to change my 125 into 5 cubed. Okay, that's what I changed my 125 into. And that is to the 1/4 power. So when I start simplifying, here's my 5 to the 1/4. This part, when I have a power to a power, I need to multiply those exponents. So that part will simplify to be 5 to the 3/4. Now my bases are the same. So the rule says I should keep my base, add my exponents. And that will give me 5 to the 4/4, which is 5 to the 1st, giving me just 5. Okay, because I wrote out every single step of this one, it looks longer. As you practice more of these, you will probably leave out this step and this one, so it's not really any longer. And there are some problems that you will only be able to do this way. So, all right, I want you to try these 3 got it questions. So go ahead and pause the video, try these 3, and then when you're done, come back and check it with mine. All right, I'm going to change this one to radical form. 64 to the 1/2 is the same as the square root of 64 to the 1st power. Well, so the square root of 64 is 8. So this one is a multiplication with the same bases. So I'm going to keep my base, add my exponents. So I get 11 to the 1st power, which is 11. For this one, I don't know that I can make my bases be the same, because this is, 3 to the 1/2. I can't rewrite 12 as 3 to a power. So this one I'm going to have to work in radical form. So it's the square root of 3 to the 1st times the square root of 12 to the 1st. Gives me the square root of 36, which is 6. So now, there is a special rule. So here's the thing. We know that I can take for this one and put the exponent over the index, and that's going to give me a to the m over n. But for this one, that exponent isn't on the a. It's outside the parentheses, but we can do the same thing here. There's your a to the m over n. That's what this says right here. It's a little hard to recognize that just because it's really almost looks like a and then mn is next to it, but it's an exponent. I'm going to get rid of that. So I just want you to focus on these here. So your m, your exponent, can be underneath the radical with your variable or your number, or it can be outside the radical, outside those parentheses. But regardless, you're going to put that exponent over the index. All right, so let's practice a couple of these, just writing them in different forms. Okay, for this one, I want to write it in radical form. So this is my exponent. This is my index. So my index is 7. Here's my x. My exponent goes out here. Now this one is in decimal form. It's not in fraction form. But 3.5 is the same as 3.5, which is the same as 7 over 2. So I'm going to write that. This is the exponent over the index. So that's going to be the square root of y to the 7th. But we have to simplify it. Okay, so 7 over 2 gives me 3 and 1/2. So this is my simplified answer. for part B. They want me to write these in exponent form. So write down my variable, put the exponent over the index. Variable, exponent over index. And that's it. Okay, I'm going to stop this video here and then we'll pick up with another one in just a second.